All right. So I'm Tashiana, and we are going to be talking about rewriting formulas to solve math problems. So information in this lesson is coming from the Math Sense and the Number Sense Advanced Equation packets. So what we're going to be talking about, first we're going to look at some common math formulas. So these are formulas that are used to solve different problems. We'll go through them and just kind of go over what they mean and everything. And then we'll show how you can use algebra techniques to rewrite the formulas to solve the problems. And then, of course, we'll practice problems throughout the lesson. All right. So first of all, the main concept is that we can use algebra to rewrite common math formulas to solve problems. So this chart just shows some common formulas, and I believe you'll get a formula sheet when you're taking your test. So these are just examples of some. You'll probably have these, you may have others. But so for example, distance, simple interest, temperature, and these are the formulas, and then we'll also have the variables that they represent. So you'll use these formulas. Sometimes you may have word problems just to solve for whatever missing variable that you have. Let's keep going. Uh-oh. There we go. Sorry about that. So the steps to rewriting formulas. So when you rewrite them, you create equivalent formulas. So we're not changing the values of the variables. We're just rearranging to solve for a missing variable. So for example, well, the first step you'll do is you'll read the whole problem so you can figure out what variable you're looking for. And then we'll determine which formula we need to solve the problem. And then we'll rewrite that formula in terms of the variable that we're trying to find. Then once you do all of that and you set up your new formula, you'll plug in the values that you have. And then once you do that, you'll be able to solve for that missing variable. So we're going to go through some problems to show how all these steps work out. So this example is using a distance formula. So D equals RT, which is distance equals the rate times the time. So here's a common problem where we aren't rearranging the formula yet. We're just plugging in values. So Bill drives at an average rate of 70 miles per hour for 2 hours. How many miles does he travel? So first we need to figure out what formula we need. We know in this case it's the distance formula. So D equals RT, and then we can plug in what we have. So we know we have the rate, which is 70 miles per hour, times the time, which they gave us 2 hours. And we multiply those together, we get 140 miles. So the distance that Bill traveled was 140 miles. So that part is pretty clear cut. We just plug in those values and solve the problem using the formula exactly as it's written. You may get a problem, however, where it's not as clear. So Bill drove 140 miles in 2 hours. What was his average rate of speed in miles per hour? So here we looking at it, you know you're dealing with distance, but they're not asking us to find the distance this time. So we have to rearrange the distance formula to figure out what we're trying to find. So the first thing is, what are we trying to find? And in this case, it is his average rate of speed, and rate in this formula equals R. So that's what we're trying to find, our R. So I'm going to rewrite the formula, D equals R times T. And then I'm going to look at it. If I'm finding R using the algebra techniques that we know, in order to get R by itself here, if I'm multiplying by T, I have to do the opposite to get rid of T on that side. So I'm going to do the opposite and divide by T on both sides. Because remember, what you do to one side, you have to do to the other. When we do that, those T's are going to cancel out, and you'll be left with D over T equals R. So using the distance formula, distance equals rate times time. we just found that we can find rate. Rate equals the distance divided by the time. So now that we have our newly rearranged formula, we can plug in those values that we have. So I just rewrote it over there, retyped it. And we plug in what we have. So D, our distance they gave us, is 140 miles. The T, the time they gave us, which is 2 hours. So 140 divided by 2 equals our R, which is 70. So Bill's average rate of speed is 70 miles per hour. So this was just a quick, using this formula, quick way to see how we took D equals RT, rearranged it to solve for R, which was our missing variable, and we got the answer. So if you look at the first question, they gave us the rate, they gave us the time, we needed to find the distance. Here they gave us the distance, they gave us the time, we needed the rate. So you still have the same values because we didn't change the values, we just rearranged our formula. And so we created that equivalent formula. Okay. So I keep doing it. Okay, let's look at another one. So this one uses the simple interest formula. So I, or interest, equals PRT, which is the principal times the rate times the time. So this example is Jenny paid her brother $480 in interest on a $4,000 loan. Find the number of years of the loan if she borrowed the money at 4% simple interest. So we did our first step. We read through the whole problem. You would think, okay, well, what formula do I need? In this case, you already know. It's the interest formula. So it's I equals PRT. And then we need to figure out what variable we're looking for. So they wanted us to find the number of years of the loan. So that's what we're trying to find. And the number of years in this formula is represented by T. So we're trying to find T in this case. So I'm going to bring my formula down. Now looking at this, I need T by itself. And right now I have P times R times T. So I would do the opposite operation. So I'm going to divide by P and I'm going to divide by R. So I'm just going to make it divided by PR because that didn't change. It's still multiplied together. What I do to one side, I have to do to the other. That PR cancels out on that side. And then I, or interest divided by the principal times the rate, gives you the time. So this is our new rearranged formula. So now we're going to plug in our values, and I just wrote it over there. So 480, that was the interest in the problem, divided by our principal, which was 4,000. It was a $4,000 loan, times the rate, which remember here, so they told us 4%. So if I wrote a percent in decimal form, percent is really just 4 divided by 100, right? It's 4 out of 100, which is 0.04. And then once you work out that calculation, you'll get that T equals 3. So what that's saying is that her loan was for 3 years. Okay, so I'll give you a minute to look at that again before we move on. Okay. So the next one, let's talk about the area of a triangle. So you may get the formula, well, maybe on your list, that the area of a triangle is 1/2 the base times the height. So this example, this is the formula for finding the area of a triangle. It's just like I said, A equals 1/2 the base times height, where A equals the area, B is the base, and H is your height. So using this triangle below, find the length of the base. So we're trying to figure out this entire section. So that's our variable, B. So we're trying to solve for B in this case. So I'm going to write my formula over. So now this one's a little different than the others because we have this fraction, right? But we still use the same opposite operations that we do if we were solving any algebra problem. So I'm going to type it this way. So if I'm multiplying by H, I'm going to divide by H. And then if I have a fraction here, so the opposite, the way to get rid of this is I'm going to multiply by the reciprocal. And remember, the reciprocal is just the fraction flipped. So I'm going to multiply by 2 and divide by h. And I'll do that on both sides. And of course, that h is going to cancel out, and then those 2's will cancel out. So just to repeat that, the h, since we're multiplying it, we'll do the opposite. So we'll divide. And then to get rid of the fraction, we just multiply by the reciprocal, which is 2 in this case. So you're multiplying by 2 divided by h, so you can write it as 2 over h. Those 2's will cancel out, and then those h's will cancel out. And then, okay, so then you'll be, what you do to one side, you have to do to the other. So it'll be 2 times a divided by h equals b. So now I wrote it a little differently here, but it's the same thing. If I'm take a and I multiply it by 2 over h, this is how it'll look. So now I have my new rearranged formula. I'm going to plug in the values that I have. So using this image here, of course, I just wrote it over. And then I have 2 times our area, which is 414, divided by my height, which is 18. That'll give me my base, which is 46. So the length of the base is 46 inches. So I'll give you a minute to look at that. Sorry about that. Here we go. Okay, so let's move on. So just using another formula, circumference of a circle, which is C, which is the circumference, equals 2 pi r. So 2 times pi times r, which in this case is radius, okay? So here's our example. A circular wading pool has a circumference of 98 feet. So all the way around is 98 feet. They want to know what is the approximate radius of this pool. And then also, sometimes they'll tell you, like, remember that pi is 3.14. So this pi, even though it's a symbol, it represents a number, and that's a number that won't change, it's constant. So let's figure out what we're trying to find, which is pretty clear. It's our radius. So that's our variable. So in this case, we're trying to find r. So I'm going to rewrite that over. And then here, we're just multiplying everything. So if I multiply 2 times pi times r, and I need r by itself, I'm going to divide by 2 pi on both sides. That's going to get rid of the 2 pi on this side, so I'm left with r by itself. And then r equals c, or the circumference, divided by 2 pi. So that's our new rearranged formula. And now, just like we've been doing, we plug in the values. So I wrote it over. So we knew that c, or the circumference in this case, is 98 times 2, which was already given, and then pi isn't going to change, 3.14. And so then when you calculate that, you'll get that, oops, excuse me, that should be r, sorry about that, is 15.6. So the approximate radius of the pool is 15.6 feet. Okay. So even though we're using different formulas, I think hopefully you're starting to see how we just take our formula, we use algebra techniques, excuse me, to figure out which variable we're looking for and how to get it by itself. Once we have our new formula, we plug in the values we have and it'll give us our answer. So let's do another one. So this one is the volume of a cylinder. So this formula is V, or volume, equals pi times r squared times your height. Okay. So, I don't know why I keep doing that, sorry. So here we go. Colby, a farmer, filled his silo with grain. The silo is in the shape of a cylinder and has a radius of 7 feet. If the silo has a volume of about 4,000 cubic feet, what is the approximate height? Remember that pi is 3.14. So here, figuring out what we're looking for, they want to know the height. So we're looking for h. Okay. So our first step is, well, that's what we're looking for, height. We're going to write our formula out. And we know we need to get h by itself. So I am going to divide by pi r squared. And what I do to the right, I have to do to the left. So those will cancel out. So now here's my newly rearranged formula. The height equals the volume divided by pi times r squared. And now you know what to do. We plug in the values that we have. So our values, we know that V is 4,000 in this case. Pi isn't going to change. It's going to be 3.14. Our radius was 7, but remember it's squared, so it's 7 squared. And be careful and remember that this square only applies to the r. So when you're working it out, or whether you're working it out on paper or you put it in the calculator, you want to make sure that that square is only with whatever your r value is. It's not the whole thing. So once we do that, you'll get about 25.99. So the approximate height is 26 feet. Okay. So I'll give you a minute to look at that. Okay. So now we did circumference of a circle. So now let's do a problem with the area of a circle. So the area of a circle is equal to pi times r squared. So the area of a small fountain is 361 inches squared. What is the radius of the fountain? And then once again, remember that pi is about 3.14. So here, the variable we're trying to find is the radius. So it's our r. I'm going to rewrite that formula down there, and I need to get r by itself. So the first thing I'm going to do is I'm going to divide by pi on both sides. Okay. Those will cancel out over there. And I'm left here with a over pi. But remember, r squared isn't the same as just r. So we need to get it to be just r. So in order to get rid of a square, the opposite of a square is a square root. So we'll take the square root of r squared, and we have to take the square root to the left, because what you do on the right, you do to the left. That'll get us r by itself. So r is equal to the square root of the area divided by pi for this formula. So just to repeat that, once we divided by pi here, we were left with r squared. That means r times r. We still just need one r. So in order, the opposite of a square is the square root. So what we do to one side, we have to do to the other. So we take the square root of r squared, and then we take the square root of the area divided by pi, and that'll leave us with r by itself. So now we have that new formula that we needed, the rearranged formula. And then we can plug in our values. So they told us the area was 361. We know that pi is 3.14. So we'll divide that and then take the square root of the answer we get, which is about 10.72. So then the radius of the fountain is about 10.72 inches. So it's kind of like the other one. You want to be careful when you're solving, especially if you're plugging in the calculator. You want to make sure that the 361 is divided by 3.14, and that you're taking the square root of that answer. Okay. And then, all right. So just to conclude, what you see through the formulas is that we can use algebra techniques that we already learned to rewrite some common formulas that we have to solve different problems. And then when you rewrite those formulas, you create equivalent formulas. So we're not changing the values of anything, we're just rearranging. And then to write that equivalent formula, use the same principles and rules that we used before to solve equations. So I just did a few just to show you, sorry about that, just to show you how it works with different formulas. But as you can see, as we went on, it's the same steps. So we want to read through the problem. We want to figure out what variable we're finding. And then we want to make sure that we have our equation and that we use those algebra techniques to rewrite a newly arranged formula. And then we can just plug in our values and figure out what we're solving for. So I hope this helps. Like I said, the formula sheet you'll be given for the test. So just knowing what formulas to use in your problem, it'll help you know how to rearrange them. So I hope this helps, and we'll be able to solve different word problems using different formulas. Thanks.